Hi viewers, I'm Srijit and I'm a civil engineering graduate. Probably you have seen this video before, but without audio. I got so many requests for making an audio narration for this. So today I'm going to guide you through the basic steps of doing a simple analysis and design problem in SAP 2000. I use SAP 2000 version 14 and I think this is the latest version. And if you got an early version, although you may get confused with layout and some terms in user interface comparing with this, but the basic procedure remains same. So let's get started. First things first, start a new file. In the new model window, you can see many templates. Set the units to the way you want. Set the 2D frame, go for the model type. You have two other options as well. Set the number of stories to 10, number of bays to 4, height 3 width 6. You can use your own dimensions, of course. For the time being, forget about the section properties. Okay. Now we have got two windows. One of them 3D view of the frame. Let's get rid of that. Now we have exit plane view at y equals 0. You can set up the options to review using these buttons. Okay, now we have to define some data needed for this app. First of all, it's section properties. Go to define section properties and frame sections. Section properties and frame sections. In SAP, frame section means column and beam section. So we have a default property set there. Steel, don't want steel, concrete, and also the concrete. And we have templates. We set a rectangular for that depth and width is there. We will set it up to 0.6 and the width to 0.23 width of the wall. And so we had to set the design type to be column. We have a bunch of options there. Column duration, confinement, design to be designed, okay. And I had to give a name, proper name to the section. This will give, I will give GFC, that means count 4 columns. And we can add a copy of the property. We can give another name, that is FFC, that is first 4 columns. For first 4 we will give a slightly lesser value for the width and actually depth, that's 0.45, and concrete for the column. And okay. Now we have to add a copy of that, but then we have to define a beam section, that is GFB, that is down 4 beams. And as it is a beam section, we will change the depth to 0.5 and 0.3. And this is a beam section. We have to go for B means beam, and we have to go for the concrete reinforcement and set it to beam. Okay. Similarly, you can define other sections as well. We have 1, 2, 3, 4, 5 sections here for 2 column sections and 3 beam sections. FFB, we have an extra beam sections called roof beams. Okay, RB. And now we have to set the defined load pattern. Now we have a default load pattern here. Load pattern name is DAD, type is DAD, self-weight multiplier is 1 because the SAP will take care of that load if we set the self-weight multiplier to 1. And we type a new pattern name, that is live, set the type live, set the self-weight multiplier to 0, add it, and we have another load, that is a quick load EQ, and the type to quick. And we can set a auto load lateral load pattern for the quick, that is IS code I will select, add it. We can modify parameters for this lateral load, that is modify lateral load pattern. And we have a bunch of options here. We can set the parameters. Don't do anything unless you know what you are doing. And the load pattern is right, the 3 load patterns, that live and quick. And now we have to just for knowing, I will set the preference, design, concrete design preference, and set the design code to IS code. I will set it to IS 456 as well. Okay, now we have to define the load combinations. Okay, we can create our own combinations, and I will set the default design combinations as per the code. We have 8 different combinations here. Okay, now assigning is over. We have to define. Before that, you have to select the supports. Okay, select the ground supports and assign join or restraints, and click fixed support icon there. Click OK. Now we have the fixed support in the graph. Okay, now select the ground floor columns and set it to GFC. That's for setting. We have to use assign frame sections. Instead of define, we have to go to the assign section, assign panel. So select all other beams, first 4 beams, and give assign frame sections, and give the EFC. No, FFC, I think. Yes, FFC. Okay, now select the ground floor beams, and now assign a frame section, that is GFB, I think. GFB, yeah, GFB, yeah, GFB. Okay, now select all other beams except the roof. Okay, select all other beams except roof. Sorry, now we don't want the ground floor beams. Press escape to deselect, and now select all other beams except the roof and ground floor. Okay, now select it and assign it frame sections. For that we have FFB. Okay, now select the roof beams, 4 roof beams. Now assign it the roof beam section RB. Okay, now the assigning, we have to define also. Okay, now in the frame section we have to get rid of that default section, F1, that is a steel section. Don't bother about that. And now select the roof beams, go to assign frame loads distributed, and give a value of 25. Make sure the load pattern is live. Select the all other beams. Of course, we can select the ground floor as well. Yes, and we can give the frame loads distributed. Make sure the load pattern is again live. Make sure the newtons, and we will give a higher value, 45 kilonewton per meter, and save the model. Now the modeling part is over. Our part is over. The rest will be done by the SAP, and for that we have to click a button, play button, or the analysis button, or else you can click the F5 key on the keyboard to run the analysis. In that modal analysis, we don't want that. Click the run, do not run case. Click the run now. The analysis will be done, and we are seeing the deflected shape animating on the meter. We can start and stop the animations here, and we can show the deformed shape by clicking F6, or go to display show deformed shape. We can view the different combinations, deflected shape for the different combinations and the different loads, earthquake, dead, live, etc. And you can use these arrows to see the animation in the front with the animation. Now we can go to the show forces, stresses, times cables. You can see the shear force, bending moment diagram, etc. Now set the shear to 2 and select a case. Now you can see a colored diagram, which is shear force diagram. Right click on any column or frames, or column or beam actually, and we can see the minute details of shear, bending moment, deflection, etc. for the different combinations. And we can scroll through each and every frames to find the stresses at each section. Okay, you can use these arrows to find the resultants also for this. You can see the moment 33 for the, you can see the live, dead, extra. Okay, this is also a color diagram. This is the bending moment diagram for the earthquake, live, etc. Yes. Now we can start the design. Configuring design, start design of the structures. Yes, the design is over. Yes, the design is over. You can see the results as the area of reinforcement required. This is in millimeter square, I think. Yeah, it's in different. You can say the millimeter square. Yeah, yes, it's the millimeter square. The millimeter square area of reinforcement are designed by the SAP. Okay, that is it. Now you can save this structure, and that's it for the first part, the basics. And actually any 2D structure or 3D structures, of course this is the basic one. Advanced options are available in this software. Also, now this exercise, the model we analyzed was made from template. Most often templates didn't match our structures, so we have to start from scratch Also, the whole process of modeling of the structure will take time and will become more complex. So please make it sure to catch my other video, SAP tutorial to modeling, to learn modeling techniques in SAP. Goodbye and good luck. Have a nice day.